So same idea. I have a piecewise defined function, and there are two parameters here. There's an unknown parameter A and an unknown parameter B. And I again want you to find the values of A and B that would make this function continuous at x equals 0, or show that no such values exist. So why don't you take about, let's say, 3 minutes and some change to try to figure this out, write out the whole solution. And then we'll finish it up. We might finish it up tomorrow at the beginning of class. It's okay. But this is very similar to the previous example. Okay, so let's look at this. All right, so quick review. How do we solve this problem? What is the general strategy? What is the fundamental strategy that we're using for this type of problem? Shield, left limit equals right limit equals function value. Colleen, limit of x approaching 0 from both sides must equal f of 0. Iqbal, find the right and left limits and function value to see if they're equal. Good. So let's write that down. So we must have lim as x approaches. So I only care about x equals 0. So limit as x goes to 0 from the left must equal limit as x goes to 0 from the right. And that must be equal to f of 0. And like I've said, these limits will in principle depend on these parameters, and that's perfectly fine because then we're going to solve for those unknown parameters. All right, so let's go one by one. So 1, what is the limit as x approaches 0 from the left? Try to keep the function on the same page. Well, I use the first piece, x plus a, and so I directly substitute x equals 0. All right, just like what Hoover wrote in chat, 0 plus a to get the direct substitution, and so that means the left limit is just equal to a. Second, what is the limit as x approaches 0 from the right? Now I have to do the limit of sine of bx over x. So good. Again, Hoover wrote what she wrote in chat is correct, right? Let's multiply and divide by b, right? I'm going to put an extra factor of b in the denominator, but then to compensate, I also need to have an extra factor of b in the numerator, right? Notice that these two things are the same because the b's would cancel out. But we discussed last week, so this is a special limit. Sine of bx over bx as x goes to 0, that has limit 1. And this constant here, this just has limit b. So overall, this limit is b. The left limit is a, the right limit is b, and now we have, okay, the function value. So the function value is equal to 5, right? We're using that middle piece there. The function value is just 5. So all three of these numbers must be equal to each other. A, B, and 5. So clearly, A and B are both 5. I mean, right? It's there's really nothing to solve for. Like you're kind of just giving it to you directly. So, and just in the last minute,